Okay. I think we can begin. Manish will be able to follow soon. Bethany, kindly lead us in prayer.
Yes, let's pray. Dear Father in heaven, thank you for another day of life that you have given us. Thank you for this class that we're in, and I pray that as we study and that we learn, that you give our teacher wisdom in explaining to us and give us wisdom and understanding, and send your spirit and help us in all things to remember that mathematics helps us to better understand your character and who you are, and that you are the one that created mathematics. Thank you, and I pray these things in Jesus' name. Amen.
Amen. Thank you. Okay. Yes, so any question, any comment, especially in our last quiz? We just it appears that what's this? This linear models applications, you need to um, be more familiar with them. I know that it's kind of difficult it's a challenge to translate the problem into mathematical language. But yeah, we'll have more of those so you can practice as we move on with, particularly when we move on to rational expressions. And one thing is we are just, only after this week, that will just be 2 more weeks. So we hope we'll be able to cover just the right amount of material that would be necessary for you as college algebra students in your area of specialization. So we will, if I think you know where you went wrong, and don't worry. In the final exams, I won't be giving you a very, very difficult problems. Giving problems that are just very those that we have discussed in class, maybe very similar ones. Okay, so let me just share my screen so we can continue with our discussion. Okay, yes. All right, so we ended, I think we finished our discussion last time. We talked about addition, subtraction, multiplication, and the division of some algebraic expressions. Particularly, I'm talking about functions. And of course, the uh, composition of functions. We have GOF and FOG. So we'll proceed from there, and I think this will be the last section on the area of functions and linear functions, and then we'll move on to the chapter on polynomials and on rational expressions. Okay, so previously we said that when you talk of functions, we want to make sure that our input would be unique, that there's only one input. We could not have two inputs having the same output. And so I have these two figures here. So there are two ways we can have functions. One is one input and one output. And how do we call that? And there's one input, one output.
I don't remember that.
One input, one output. So we call that one to one. You remember? Okay, we have what we call one-to-one function. We have one input and exactly one output. So that's one-to-one. However, we can also have function where you can have two inputs, but there's only one output. Like maybe you talk about function f of x is equal to x squared. If your input is 2, your answer is 4. If your input is -2, your answer is also 4. So it's not about the output. You can have several outputs as long as you have only one input, your x, definitely. And so when we have that kind of pattern for your function, what do you call that?
Many to one.
All right, so we now call that many to one. So there are two, we have one to one, many to one. But if you have one to many or many to many, that will just be considered relations and not necessarily functions. So you would notice that if I reverse, I make my f of x as my x and my x as my f of x. If it's one to one, the result will still be a function, right? But if in a many to one, if I reverse such that my y becomes my x and my x becomes my y, that won't be a function anymore because you will have two different inputs, but only one output. All right. So we will be talking now about inverse functions. So we're saying that a function can only have an inverse if it is one to one. So this is now our definition. We say if the function is one to one with a domain A and range B, and then we can have what we call an inverse function where we say the domain of B, the domain B and the range will be interchanged. All right. So the domain A in the function, range B in the original function. If your domain becomes B and your range becomes A, then that is now an inverse function. So we say the domain of the inverse function is the range of F. The range of the inverse function is the domain of F. So please just take note that we'll be using the symbol F to the negative 1 of X. Whenever we're talking about exponents, we say that if you say x to the negative 1, that is 1 over x. But that is not how it would be here because it is just a symbol for our inverse function. So don't think that f to the negative 1 over x is equal to 1 over f of x. That is only for exponents. But the f to the negative 1 here is not the exponent. Rather, it is just a symbol that we have what we call the inverse of a certain function. All right. So let's now go ahead. All right. So now I think in life, we also have some inversion processes, right? We do inverse process. Okay. So Sane, kindly read this.
An inverted roller coaster is a ride where the cars run underneath the track. They travel along rather than above it. An inverted airplane is one that flies upside down. Inverting the colors on a photograph will turn black colors to white and white colors to black. Inversion is the process of reversing the order or position of something.
All right. So that's just the idea of inverse function. It's just reversing the order, reversing the process. So instead of x, it will become y. Instead of y, it will become x. So that's a simple understanding of inverse function. And that's the way we should be able to look for inverse. So for us to find the inverse of a function, given a certain function, we know that y is equal to f of x. So we have begun talking about that previously, that we are now changing your y to f of x. So we say y is equal to f of x. So for if you have a certain f of x, the first thing that you'll have to do is just replace your f of x by y. And then you just interchange x and y. So instead of x in the equation, make it y. Instead of y in the equation, make it x. And from there, we solve for y. So it is very much solving equations. Okay, so maybe let's just have an example of this one. So like if I have f of x is equal to x plus 1. What we do is change, instead of f of x, make it y. So it's y is equal to x plus 1. And then we switch. Instead of y, we change it to x. Instead of x, we change to y. And then we solve for y. So now the y equals x plus 1, we are now changing it to x is equal to y plus 1. And of course, you know how to solve the equation. we transfer you solve for y now. So we subtract 1 minus 1 so that we will have our y to be isolated. And of course, transfer that to the other side. So that's x minus 1. So our inverse of the function x plus 1 will just be y, which we will change to f inverse of x is equal to x minus 1. All right, so those are the steps. Just change your f of x to y, interchange the position, and solve for y. And that you get your inverse of a function. And that we will check whether that is later on, whether that is an inverse, that is still a function, but we're just saying this is the way to find the inverse of a function. All right, so let's begin with number 1, okay? Yeah. So maybe try. So let's just do a little. You can tell me what to write. Okay. So for number 1, what do we do first?
Substitute f of x
All
with
right.
y.
Instead of f of x, we just change that to y. Okay. Is equal to 2x to begin with. 2x plus 9. So instead of f of x, change it to y. Then we switch. This now becomes x is equal to 2y plus 9.
Solve.
Then solve for y.
Yes, solve for y.
So what's your value now? What's the final answer?
It will be y is equals to minus x plus 9 or 9 minus x over.
I think it's better. It's okay to retain the 2y on the right hand side so that you don't make that a negative. All right. Anyway, because we know that it is symmetric. We can just the y at the right side can be transferred to the left side later on. So what we can just do is, so that you don't have all the negatives, you just say x minus 9, transfer 9 to the other side is equal to 2y, right? And then we just divide by 2, both sides. So you will now have, so as I was saying, you can just interchange the position as long as you put the y at one side and the other side, you don't have to change the signs there. So we just divide both sides by 2. So it will now be y is equal to x minus 9 over 2. Actually, you can just say x minus 9 is equal to over 2 is equal to y. But again, because it's symmetric, I can just put the y is always our f of x is at the left-hand side. So then, after that, you just change your y to f of negative 1 of x, which is the symbol of the inverse of the function, is equal to x minus 9 over 2. So that is now the inverse of the function f of x is equal to 2x plus 9. All right. So will you please try number 2? F of x is equal to 1/3 x minus 1.
3x plus 3 is equals to y.
3x plus 3. Okay, did everyone get that?
I'm working on getting it. Yeah, 3x plus 3.
All right, so that's 3x plus 3. All right, so just for the record, let us uh, let us do that. So just as we say, we'll have to change this to y is equal to 1/3 x minus 1. And then we interchange the position. X is equal to 1/3 y minus 1. All right, so you can just transfer your plus 1 to the other side. You say x plus 1 is equal to 1/3 y. And we can just cross multiply 3x plus times plus 1, okay, is equal to y. So you now have 3x plus 3 is equal to y. And so you say f of -1 of x will now be equal to 3x plus 3. Very good. All right, that last one. These are now both having numerator and denominator. So we now have a rational expression there. 3x over 2x minus 1. Okay, maybe I can now erase all ink on the slides. So Rachel, can you tell me what will be your first step?
Not sure.
Okay, so we say instead of f of x, we will change to
Y.
y, okay? Yeah, equals, then just copy first to begin with that. 3x over 2x minus 1. As soon as you have changed your f of x to y equals 3x, okay, and then just copy your function. And then we now make interchanging, all right? So then what do we do? So we say
Interchange
instead of y, we will change to
X,
x. Yes, good. Equals. So then this becomes now 3.
Y,
Yes, y over
2y minus 1.
2y minus 1. Yes, that's right. And then we will now solve for y. So then with that, what do?
Times
You multiply both sides by 2y minus 1, right? So that we can get rid of 2y minus 1 as the denominator, or in forms of, when you do that shortcut, you just say cross multiply, all right? So we now say x, we multiply x by 2y minus 1 is equal to 3y. So that becomes much simpler because you do not have your denominator anymore. So I think from there, you can solve for y.
Yeah, y is equal to 2xy minus x over 3.
Y is equal to, that the y must be, you should not have y in your final answer except for the y at the right side. You do not just say
Well,
y is equal to x is equal to x, what did you say, y over 3? 2xy minus x over 3 because the y must be isolated. There's only one y. And your answer at the right side will be all x, okay? So what do we do here? You now, okay, do this. 2xy minus x, right? Is equal to 3y. So put together the value, the expressions with a y and transfer to the other side the one with an x. And then you can do factoring. So this one has a second step. All right, so what do? You just say 2xy minus 3y, transfer to the other side, is equal to x. Are we together? Yeah, so I'm transferring. And then there's something common with 2xy minus 3y, right?
That's why.
All right, so y is common, then factor it out. Do you now have 2x minus 3, right? You factor out your y, so it will now be 2x minus 3 is equal to x, correct?
Yes.
Yes, so what will be your final answer there?
Y is equals to x over 2x minus 3.
All right, x over 2x minus 3, and then just change it to f of negative 1 of x is equal to x over 2x minus 3. Yes, so sometimes our factoring needs, you say, or factoring is necessary in some cases. So usually if it is just a linear function, that's kind of a little easy, but when you now have a rational expression or a rational function, then you will have to remember some of the principles that we have discussed and apply them.
I
Yeah.
missed the step where we went from factoring the y out, so y times 2x minus 3 equals x to y over 2x minus 3
Yes.
divided by 2x minus.
Yeah, so we divide both sides by 2x minus 3 so that you will just have y as an isolated variable. So you divide y, 2x minus 3 by 2x minus 3. You divide x also by 2x minus 3.
Okay, that makes sense. Thank you.
All right. Yes. Yeah. So yeah, in your homework, I'll be giving some things for you to practice. But at least we have an example of different types of functions. Pull up says a linear function, and then a linear function with fraction as one or as the coefficient, and of course your rational. We call it a rational function, where you have a numerator. There's a variable in the numerator, and there's a variable in the denominator. All right. So now this one is just, we're saying this is the inverse of the function. But the question is this inverse also a function? So we'll just move on to, so given certain, you have now a function, you're looking for the inverse of the function. The question is that inverse also a function? So that's the next thing we'll be considering. All right, so we're still on inverse functions. Now, in this situation, we will be using our understanding of the composite functions. So this is now the principle that we will be applying, that if two functions are one function is two functions are both functions, the inverse as well as the original function, if and only if it says the composite function of f, o, g, x as well as g of f of x will also be equal to x. So we will practice our composite function. So we now talk about f of g of x is equal to x. G of f of x is equal to x. Right. So let us going back to our previous, just for the previous. Oh, that one may be a little okay. In the previous example, where we now have f of x is equal to 2x plus 9, if you remember that, f of x, the number 1, is equal to 2x plus 9. And then we got the inverse of f of x was what was that? X minus 9 over 2, the one that you got as an answer?
Over 2.
Yes. Question is f of the inverse of f of x still a function? So we want to say whether the inverse is also a function. So in our symbols here, instead of f inverse of x, we can put that as just g of x, so that, sometimes that f inverse can be messy, all right? So you say f of x is equal to 2x plus 9, g of x is equal to x minus 9 over 2. So first, we would want to know f o g of x. You remember what we were doing last meeting? So this is the same as f of g of x, where we're saying instead of x in your f of x, we substitute the g of x. Okay, so we'll do that. 2, instead of x, I'll put x minus 9 over 2. Is that okay?
Yeah.
Yes. Then plus 9. So 2 and 2 will cancel. Therefore, that cancels. This is now x minus 9 plus 9 is equal to x. So we were able to show that f of g of x is equal to x. Will you please check if g of f of x is also equal to x? Okay, can you do that? It's now you reverse. Instead of x in the g of x, change it to the 2x plus 9. Okay, will you please just do that for me? So it's the other way around. Instead of x, all right. Instead of x here, substitute 2x plus 9.
Oh,
All right. So instead of your x, put 2x plus 9 here and solve.
the f of x.
That's 2x. That's x.
All right. Yeah. So instead of x here, you put 2x plus 9. So you get 2x plus 9 minus 9 over 2.
2x over 2.
All right. So that's what you're saying. So you say it is now equal to, sorry.
You
So
take the
you get x?
x minus 9.
No,
Instead
instead of x, you put 2x plus 9 minus 9 over 2. Is that it?
Yes.
Yes. So 2x minus 9. I saw it for that. 9 minus 9 is 0. So you just have 2x over 2. Then you get an x. And therefore, we're saying that the two are inverse functions. Both of them are functions. Okay. All right. So let's just, okay, that one is just, I just want to go back to what we did a while ago. And in most cases, when it is a linear function, we really would be able to see that the inverse is also a function. Okay. So let me just erase that, and I will just give another example on the slide here. Okay, so similar to this. If you now have f of x is equal to 4x minus 7. Okay, so, and that your g of x is x plus 7 over 4. So you say f of g of x, so f of x plus 7 over 4, which means that instead of x here, you substitute x plus 7 over 4. So 4 times x plus 7 over 4 minus 7. So you get x plus 7. So 4 and 4 cancels. So you now have x plus 7 minus 7, you get x. Similarly, g of f of x means instead of x in your g, we substitute 4x minus 7 because that is your f of x. Okay? So instead of x, you make 4x minus 7 plus 7 over 4. So you now have 4x over 4 because 7 and 7 will be 0 minus 7 plus 7. And that will also be equal to x. Okay, so that's how it is. So let's have some practice here to check. Okay, let's begin with number 1. Yes, you want to ask a question?
No, we were just copying from the slide onto paper, but it's okay.
Yeah, so
Oh, okay, okay. Of course, this one, I usually put it up on the website, so you can go back to that too, all right? Yes.
So we're good. We're
move on.
good.
Okay, so that you can, okay, let's have this as your practice. Let's begin with number 1. You So I'm not sure if maybe it is easier when you put f
One
of
is a function. I mean,
g of x. You can just put f of x plus 2 over 3. So that you know that instead of x in your f of x, you will substitute x plus 2 over 3. Okay. Yeah. And then if you have now g of f of x is equal to, you can just put g of 3x minus 2. So this is telling you that instead of x in your g, you're substituting 3x minus 2. Instead of x in your f, you're substituting x plus 2 over 3. So maybe that one will be a better guide.
first one is a function.
So did you get both x?
Yes.
Okay. All right, so you actually did FOG just for the use of the symbol. So you're saying instead of x in your f of x, you substitute x plus 2 over 3. So you know, say 3 instead of x, you put x plus 2 over 3 minus 2. Okay, in this one. And I think that one is seen. You know, have 3 and 3 cancels. X plus 2 minus 2 is equal to x.
And the second one.
Okay, please go to check and then see. Please just ask questions. So just the same, if you now have g of f of x, instead of x in your g, you substitute 3x minus 2.
Mm-hmm.
Yes. So you now have 3x minus 2 instead of x plus 2 over 3. Minus 2 plus 2 is 0. 3x over 3 is x.
It's also a function.
Yes. In other words, both f of x and g of x are inverses. Okay, let's try something a little not very complex, but something that will help us remember our fractions. Okay, try number 2. Yeah, sometimes when we deal with functions, that's a little, you need some good understanding of reciprocal and all those. But anyway, let's try number 2. F of x is equal to 1 over x minus 3. G of x is equal to 1 plus 3x over x.
Yeah.
Okay, this second one, all right?
Yeah, second one is also.
So you already finished, Manish?
Yes.
Writing
F
it down.
of
He's
one,
done.
F of g of x is x, and g of f of x is also x.
Okay, show. I mean, we need to show the work that it is really that f of g of x is x and g of f of x is also x. Okay, I'll give you 2 minutes or so to just try it and for sure they are inverses, but I just want to make sure that you would be able to show your work.
Oh, how do I send you?
How do I say? How do you send? You can, you can. Anyway, we will solve so that we can compare notes. Yeah, yeah, definitely you'll find x and x.
Yeah,
Um,
it's a little more complicated because you have to substitute twice. Two
Mhm.
ways.
Yeah, it's kind of a little, yeah, especially that you seem to have some little complex fractions here where you will be dealing with. It's just a matter of knowing how to, I mean, considering reciprocal, that if you have a denominator, you invert, okay, and multiply. So that's the idea of division. Yes. Okay. So I'll just erase this part. Mhm. Did all of you get also the same x? Let's see. So here you say f of 1 plus 3x over x. And this is g of 1 over x minus 3. Okay, so we begin from there so that it's easy for you to know which one to substitute and which. So at least whenever you solve in a quiz or something, I give points for every step. So, just even if you just have put on the values, yeah, and in the end maybe you got confused, you still get a good amount of points because you have put in those. I want you to. I want to know whether you understand the symbol of f of g of x and then g of f of x, and when you are able to make substitutions. So let's wait a little bit for the others to work on it. Did you get it, Bethany?
No, the fractions have me. I don't know what to do.
Okay. All right. So let us just see. The most important thing is you are able to put in. Okay. So you now say your f o g of x. Okay. So instead of x in your 3x minus 2, I put 3 times 1 plus 3x over x minus. Oh, I'm sorry. I am putting in a different. Look at that. Let me erase. Sorry. I'm putting it on the 1 over x minus 3. Sorry.
Yes.
Yes. Okay. So you now have 1 over, instead of x, it will now be 1 plus 3x over x minus 3, right?
Yes.
Yes. So once you have done that, then I say, oh, you know how to substitute. Okay.
Ah,
Yes. So then, let us first simplify the denominator. So it is 1 over. Okay. So the numerator is 1. We now have a denominator, which is also a fraction. Isn't that? That will now become 1 plus 3x minus 3x over x. Are you okay? We want to have the same denominator. So I
Yeah.
multiply by, there's only one denominator, which is your x. So similarly, when you now say 1/3 plus 1, isn't that you would just say 1 plus 3 over 3?
Mhm.
Yeah, because we now multiply this by 1/3 so that I'll have the same denominator. I multiplied it by 3, I should say. Multiply by 3 over 3. Okay? So I multiply by 3 over 3. So that's 3 times 1. And then the common is the denominator. Common denominator is a 3. So similar here. I have a denominator of x here. I wanted that the 3 should have also the same denominator as x. So I multiply this by x over x. Right? So I will now have 1 plus 3x minus 3x, and you now have a common denominator. Oh, please just ask if that one seemed to be, so it's actually really about dealing with dynamic. So in a situation like that, what would happen now? So I hope this one is clear why I have a 1 plus 3x minus 3x over x. That one will now have 1 over 3x minus 3x is 0. So I have now 1 over x. In other words, I have a denominator of 1 over x. And what do? You just multiply by the reciprocal, or you just invert and do the multiplication. So you now have 1 times x over 1 gives you x. When you have a fraction in the denominator, reverse. We talked about that previously. Reverse the denominator and proceed to the process of multiplication. So instead of x, it will become 1 over x. You just have to have 1 times x over 1. And then you get the next. Are we okay with this? Will you please just check and then ask questions? So that was fractions.
I followed most of it.
Okay. Or try the other one and then see if you can get also x. The g of f of x.
X.
So instead of x in your 1 plus 3x over x, you substitute 1 over x minus 3. Oh, Manish, you want to go around and check what they're doing so that you can see, because you already have found the answer. So maybe you can assist me.
I mean, this is not so difficult.
Yeah, Manish will check your work.
It gets harder.
Huh?
There's like
Yeah.
more
Oh,
complex.
the other one is much harder, okay?
This is just like inverse the denominator and
Yes, it's actually just the same. You just
all
have
that.
to reverse the denominator. Okay. Let me first see whether, okay, let me erase this, okay. Once, well, let me see how you first did the substitution. Let's do this together. You tell me how it is done. Okay, so let me just erase. Okay, let's do that. All right. So we now have the GOF of x. Okay. So what did you do? Now tell
Yeah,
me.
G f of x.
1.
So
Okay. All right. So instead of x in your G of x, you substitute 1 over x minus 3, right? Say 1. Okay, everyone. Say 1 plus 3 times
1 over x minus
1 over x minus 3. Are we fine?
Yes.
Yes, good. Over. Instead of x, you'll have 1 over x minus 3. Bingo. Once you get that, well, all right. Then we now proceed. What will you do?
Yeah, just find common denominator.
Okay. You want the denominator of your numerator to be x minus 3. So isn't that the same as just x minus 3 times 1? You multiply 1 by x minus 3 over x minus 3, okay? Plus 3. Is that procedure okay? So the one I have 1 plus 3 times 1 over x minus 3 is the same as 1, x minus 3, because I now multiply that 1 by x minus 3 plus 3. I multiply 1 by x minus 3 over x minus 3 so that I will have the same denominator. Over 1 over x minus 3. Oh, ask the question on that numerator that I have written as x minus 3 plus 3. Yeah, okay, so I this one, this section. Is that understood why it became so? No? So let's okay. All right.
It's 1 plus
All right.
3x.
Isn't that it is now, it says 1 plus the 3 times 1 over x minus 3 is the same as 3 over x minus 3. Are we okay?
Think of
I can
1 as
just put on the same numerator rather than times 1 over x minus 3. So I have now 1 plus 3 over x minus 3. This section, this one. So you want the denominator to be the same. So what do you do?
think of 1 as x minus 3 over x minus 3. That's it. Same thing on top and bottom. You getting my question?
Yeah. Okay. So I want the denominator to be the same. So which means I multiply 1 by x minus 3 over x minus 3.
Which one?
In that situation, I will now have x minus 3 over x minus 3. plus 3 over x minus 3. So they already have the same denominator. So I can just combine. It became
happened?
now x minus 3 plus 3
Wait,
over
hold on.
x minus 3. Are we
No.
okay?
3 times 1x over
Yeah,
3y.
to change the one
You are thinking of one as something else.
as something else.
Oh, yes.
It's
Is
9 over 9.
What?
1.
Exactly.
What is x over x?
So one should not, doesn't mean it looks one only. You just make it x over 3 minus x. So x minus 3 over x minus 3 both sides. That's 1. See, and then you have common denominator.
Yeah, I know, but the 1 in front of the parentheses. Where it's 1
Oh,
plus 3.
that means that you are multiplying 3 by 1 over x minus 3. So when you multiply 3, okay, so it's just good to remember these things. Okay, you say 3 times 1 over x minus 3 is the same as, the 3 is a numerator. That's the same as 3 over 1. So you multiply the numerator by the numerator, multiply the denominator by the denominator. So 3 times 1 over x minus 3 is the same as 3 over x minus 3. Are we okay? Okay, let me proceed before that so that it's easier to to understand. Okay. Let's do that again. Yeah, right. So you now have equals 1 plus 3 times 1 over x minus 3 is the same as 3 over x minus 3. Are we together?
Yes.
All right. So that parenthesis will be gotten rid of. Okay, so that is okay now. So let's proceed. I'll remove this. We already have done that. Okay. So how do we combine 1 plus 3 over x minus 3? So I said that is the same as x minus 3 plus 3 over x minus 3. Whenever you are multiplying, you are adding a constant or just one variable plus something that is a fraction, what you just do is multiply this one by the denominator. That's shortcut. So 1 times x minus 3 is x minus 3, then plus 3. Because that is the same as 1 plus 3 over x minus 3. We want the denominator to be the same. So I multiply 1 times x minus 3 over x minus 3. I'm multiplying by 1. It did not even change. So plus 3 over x minus 3. So the shortcut is, if it is something that is just alone, multiply the denominator by that number or by that variable. And that would show, that will already tell you that the denominator would be the same. So I hope that this section, let me erase so that that doesn't get confusing. I have very small thing to write on. The x plus 3 minus 3 over x minus 3 is okay. Is this okay now? So from here, I have now x minus 3 times 1 is x minus 3 plus 3 over x minus 3. And then I proceed. Okay. Over 1 over x minus 3. So minus 3 plus 3 is 0. So you now get x over x minus 3. But then over 1 over x minus 3, that's what Manish is saying, you just invert and proceed to the process of multiplication. So x minus 3 and x minus 3 cancels, then that will be equal to x.
Exactly equal to x over 1.
Yeah, but x over 1 is x.
If you have any questions, contact.
All right. So maybe, well, looks like So I just want to make sure that, because we will be dealing with some rational expressions in maybe by Tuesday. So I just want to make sure that you understand how to do fractions. Okay. But yeah, you'll have some exercises on this, and then you can practice. But one thing is, what you only want to see is that you will get the value as x in both. And then with that, then you will be able to verify that they are inverse functions. So this seems to be a little complicated, but I just want to show you. But usually in the exam, maybe I don't want to give the more complicated things because it will take you eternity to be able to finish. So I just want to know whether this one is clear, how it was done. I mean, at least,
Yes.
Yes. Okay, so I could not, maybe in the homework I'll give you something like this so that you can practice. Yeah. And one very nice example of inverse functions is, you're changing Celsius to Fahrenheit and Fahrenheit to Celsius. When I came here, because I came from the Philippines, Thailand, then to Africa, we're using Celsius there. Here you keep talking of Fahrenheit, so it's very important that we would be able to make conversions. Yeah, you convert Celsius to Fahrenheit and Fahrenheit to Celsius.
Mhm.
So this is an example of inverse functions. Okay, where you and we now do the conversion. So let us, just for the sake of practicing, show that these two are inverse functions. Okay, so we'll be doing that. So because we are used to x, we can change the Celsius to Fahrenheit as f of x is equal to 9/5x, because that's the one that you usually we say, what is 25 degrees Celsius in Fahrenheit? Then you put in your value, okay? Plus 32. And then instead of just c, I'll put c of x is equal to 5/9 x minus 32. All right. With that, will you please show, put it in writing, put it there. Check whether they are inverse functions.
Mhm.
Solve. That one is simple because it's only a linear equation, a linear function. You say, okay, just to f of 5/9 times x minus 32. Okay. You want to show that that is x. And then c of 9/5x plus 32, you want to show that that is x. Instead of x on your f, you substitute 5/9 times x minus 32. Instead of x on your c, you substitute 9/5x plus 32. Did you get x? Done? Let me see with your F, you put, I hope you have 9 over 5. Instead of X, you put 5 over 9. X minus 32. Plus 32. Did you begin from there?
Yes.
Yes. And so 9 over 5 and 5 over 9. 9 and 9 will cancel. 5 and 5 will cancel. You just get X minus 32 plus 32 is equal to X. Is that okay?
Yes.
Yes. Okay, so similarly with your C, instead of X on that 5 over 9 there, you put 5 over 9. Instead of X, you substitute 9 over 5. X plus 32 minus 32 in that C of X. So just the same. You now have, oh wait, what happened there? X minus, okay. So you now have, let me see, 5 over 9, X minus 32. So I put 9 over 5X. I'm sorry. It should not be, let me remove my parentheses. Wrong. I think I should not have that parenthesis there.
That confused me, the parentheses.
Yeah, there's no parentheses, okay? The parentheses should be, okay. All right, thank you. That's it. All right. So it's just 9 over 5x plus 32 minus 32. 5 over 9, okay? Instead of x, I substitute 9 over 5x plus 32 minus 32. That's it. So 32 and 32 cancels. I now have 5 and 5, 9 and 9. That will just be equal to x.
Yeah.
So sorry for putting the parentheses.
Why does the second equation have a parenthesis?
Yeah, because I put it and you just have to multiply inside the bracket.
What is it that you're saying?
The Fahrenheit to Celsius equation.
Okay, let me. All right. So this Fahrenheit here?
No, the one in
Yeah.
above, the main equation for Fahrenheit to Celsius. That one, yeah.
Fahrenheit to Celsius.
Yes, not that
Okay,
one.
so
Yes.
this is the formula, right? 9 over 5x plus 32. The other
Okay,
one
no,
is 5 over 9x minus 32. So which one are you asking?
the second one. Why is there parenthesis?
It's because when you put an actual number there to do the actual conversion, you have to subtract 32 from
Yes.
that number.
This is the formula for conversion.
I know, but a parenthesis
Changes.
also means multiplication, right?
Yes.
Yes. Here, when you substitute, when you change from Fahrenheit to Celsius, you first subtract 32 from your Fahrenheit before you multiply by 5 over 9.
So you do multiply it by 5.
While in Celsius to Fahrenheit, you multiply first your Celsius by 9 over 5 before you add 32.
Okay.
Yes, so this one is the conversion formula. So for Celsius to Fahrenheit, Fahrenheit to Celsius, I should say, subtract 32 from the Fahrenheit value before you multiply by 5 over 9. But it's different from Celsius to Fahrenheit. You first multiply 9 over 5, the Celsius, before adding to 32. Okay? So this one is our real conversion formula. But here we just want to show that they are inverse functions. So I think I just had, because it should be 9/5x plus 32, I put a parenthesis, which is wrong. So that is now 9/5x plus 32 minus 32 gives you 32 minus 32 is 0. 9/5x times 5/9 is x. Okay, I think this one is another simple, because it is like, what is this? This is just a linear function. So for linear functions, it's kind of easy to do inverse. So I'll just give some exercises, work on so that we can just proceed a little bit, all right? And so when you do your practice, I can give my feedback for things that may seem not to be very clear, because I just want to introduce. I am choosing this whole chapter. I even skipped chapter 4 because chapter 4 is linear functions. And as already mentioned, we have done a lot of linear functions in the past, linear equations in the past, which is the same. They're also talking about slope. They're also talking about perpendicular lines and kind of thing. So just introduce, we have done polynomial functions previously too. So we'll just do a little review of polynomial functions, okay? So we now talk of a polynomial function. If you remember, I was talking about algebraic expression. So it's just the same. We're just changing the symbol to say it is a function where we put an f of x. Okay. You're also talking about coefficients. You talk about the degree. So it's the same thing that we have done in the past. So some very common polynomial functions are constant function. And if it's a constant function, I think you know that you'll just have f of x is equal to 2. In other words, it will be 2 for whatever y. Okay, so that is now a line. Then you'll have a line which is horizontal. Then you'll have a linear function, which we already talked about. We have quadratic function, where you have the highest degree is 2. Then cubic, we also have done some cubic, where the highest degree is 3. And quartic, if you have the highest degree of 4. So just that different kinds of common functions that we are dealing with in algebra. And so we look at graphs. I will not ask you to graph here. We just have to have an idea of what's the picture of a graph of a linear, which you have done before, and quadratic, which we said it is a parabola that can open upward or can open downward. And this is the picture of a cubic function. It's, yeah. So, have, if a parabola, you have one way, it is, what is that? Moving up, down, up once. For your cubic, it's moving up once, move down once, and up. So there are 2 vertices there. For quartic, okay, I will have 1, 2, 3 vertices. And then quintic, if ever we now have 5, degree 5, I have 1, 2, 3, 4 vertices. So those are some pictures of the graph of polynomial functions. Okay. And so I just want some terminologies here that we need to understand. The term zero, factor, solution, x-intercept. So if you remember when we were discussing a linear function, we're saying for us to solve for the x-intercept, we set y equal to 0. All right. So we're saying like, if I have, let me, okay. If we want to know what is the x-intercept, I think you learned that we just have to set x, your y, which is f of x. This is y is equal to 0. So that if y is equal to 0, then you solve for x. That is now your x-intercept. So we call this a 0 because it is this point, all right, where your y is 0. At the same time, this is also the point that will make your equation 0 minus x plus 2. And they say it is also considered to be a factor and considered to be a solution as we move on perhaps to quadratic functions. Okay. So when we look at quadratic functions, You now have a vertex here which is 0. So if your function is x squared, all right, the solution for x squared is equal to 0 is 0. So therefore, you have one solution. Now, there are quadratic functions that we have learned in the past where our solution would be 2. Okay, this one. There are 2 values of x. All right? So f of x is equal to x squared minus 7x plus 10. These points of 5 and 2 are zeros because this is where your y is equal to 0. But at the same time, these are also solutions of x squared minus 7x. If you remember, if I have now y is equal to x squared minus 7x plus 10, if we equate this to 0, we do factoring. Can you please remember your factoring? This is the same as x minus 5, x minus 2, right? That's the factors. So therefore, your solutions are 5 and 2. So there are quadratic functions with 2 solutions, which we have learned in the past. But there are also quadratic functions that have no solution. And this is this example, x squared plus x plus 3. It has no solution. You know why? If you remember our quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? If we do b squared minus 4ac, our b here is 1. Our a is 1. And our c is 3. If I substitute b squared minus 4ac, I will have 1 minus 4 times 1 times 3. And I'll get 1 minus 12. And that will become a negative value under the radical sign. If the value in the under the radical sign is negative, then we cannot extract the root. Therefore, that has no solution. So, quadratic functions can have only one solution, can also have 2 solutions, and sometimes no solution. Of course, the maximum solution would be, the maximum number would be 2. So if we talk about the cubic, for a cubic function, you can have 1 solution or 3 solutions. These are solutions now here. Okay, let me put my laser pointer. 1 solution here and another solution there, the ones that passes through the x-axis. If it were quartic, there will be 4 solutions because it passes 4 times along the x-axis. If it is a quintic and it has solutions, then it passes through your x-axis 1, 2, 3, 4, 5. So for cubic, maximum number of solutions will be 3, quartic will be 4, and quintic will be 5. Right. So those are some functions. So now for the next, this time, since that division, we have, there's a little problem with fractions, but don't worry, we will be doing division, okay? Previously, we learned how to add polynomials, multiply polynomials, subtract polynomials, and we did division by using factoring. But here we learn how to divide if you cannot factor. So, and then we learn some shortcuts on how to do division of polynomials. So when we divide polynomials, okay, just to remember the parts of a division, when you have 11 divided by 2 is equal to 5, remainder 1. So this 11 we call dividend. 2 is the divisor. The answer is quotient. And of course, the remainder. So just remember, dividend, divisor, quotient, remainder. So we will learn how to divide now, not just numbers, but polynomials. All right, so I have some instructions here, but I think it is easier besides just reading the instructions, we will do the actual division. All right. So it says, set up the division problem, then you determine the first term of the quotient by dividing the leading term of the dividend. Those are very difficult terms. So we better just do exercises here. Okay. So I already have the actual solution, and then we'll do things together, having one problem that we can solve together. But just for our illustration, so if I say divide 5x squared plus 3x minus 2 by x plus 1, you set up the division problem. 5x squared plus 3x minus 2 divided by x plus 1. And I think that's the way we do division problem. All right? Where you have now this symbol so that you can put your answers on top of that line. So the first thing we'll have to do is the first term. Divide by the first term of your divisor. 5x squared divided by x is 5x. Then multiply the quotient here by your divisor. 5x times x is 5x squared. 5x times 1 is 5x. Then subtract, the way we're doing it in our division of numbers. Subtract. So 5x squared minus 5x squared is 0. 3x minus 5x is minus 2x. Bring down the remaining value from that polynomial. Then, again, divide this first term by the first term of your divisor. So, minus 2x divided by x will give you minus 2. And multiply. Negative 2 times x is negative 2x. Negative 2 times negative 1 is negative 2. Then subtract. Minus 2x, this becomes plus now because you're subtracting. 0. Minus 2 plus 2 will be 0. So the remainder is 0. So therefore, the quotient is 5x minus 2 with a remainder 0. And we're now saying, actually, this is an example that we have done before by factoring. You can do factoring, all right? But we need to learn how to do it. What if you cannot factor? So therefore, we're saying that 5x squared plus 3x minus 2 will have factors your divisor, which is x plus 1, times the quotient. So 5x squared plus 3x minus 2 is just the same as x plus 1 times 5x minus 2. So I have given an example of a problem that you actually could have done by factoring. Which we have done. But because we want to give an example of how to divide for a general way of division by doing the steps of the division process. I think I heard someone asking question.
Yeah, I was just wanting to make sure it's basically the same thing as factoring, but dividing instead.
Yes, that is if you are able to factor. But we'll have some problems that you cannot factor where we will have remainder. The only time you can factor is when the remainder is 0. Just like this example. But if the remainder is not 0, then you cannot factor.
Okay.
Okay, all right. So I began from there to remind you that, yeah, we have done this before, but we did factoring. But now we'll make it more general. Okay, so let's have one. Okay, so maybe let's do this together. Right. So the first thing we'll have to do is set it up as a division. So 6x cubed plus 11x squared plus 15. I will divide. I think I will run out of space. All right, let me erase. Okay, because I need some space. All right, so I'll now have 6x cubed plus 11x squared minus 31x plus 15. I divide by 3x minus 2. Okay? So please join me as we do the division. Okay. First divide 6x cubed divided by 3x. What will it
2x
be?
squared.
2x squared. Multiply. 2x squared times 3x is 6x cubed. 2x squared minus 2 is minus 4x squared. Then subtract. So subtracting, what do we get? So 6x squared minus 6x cubed minus 6x cubed is 0. 11x squared minus 4x squared gives you 15x squared. Is that okay? Then bring down minus 31x. Then divide again. 15x squared divided by
5x.
5. So it will now be 5x plus 5x. Okay, sorry for my Okay, 5x times 15x squared will be 15x squared. Minus 10x, right? Then subtract. So I will now have minus 21x, right? Because it's now minus 31 plus 10 plus 15. Then divide. Minus 21x divided by 3x minus
Negative 7.
7. Minus 7 times minus 3x is minus 21x plus 14. What's the remainder? Subtract. The remainder is 1, right? 15 minus 14 is 1. So then, your final answer will now be 2x squared plus 5x minus 7 plus 1 over 3x minus 2. That's the way you will have to put your answer. You put the quotient and then add the remainder over your divisor. So 6x cubed plus 11x squared minus 31x plus 15 divided by 3x minus 2 is 2x squared plus 5x minus 7 plus 1 over 3x minus 2. Is that okay? So we are just dividing like numbers, except that we are using now polynomials. Okay, so we'll have some. I think I have a. Right. Okay. Sorry. Okay. Are you? Yeah. Okay. I'll give you some time to copy if you're copying.
I think we're done.
We're done. All right. Let's do this. Okay. Do it. I'll give you time to do it. 2x cubed minus 3x squared plus 4x plus 5. You divide by x plus 2.
Can you have a negative remainder?
Yes,
Number?
yes, you can.
Yeah.
That's what is it? In real in numbers, you don't have a negative remainder, but for polynomials, you will have a negative remainder.
Okay.
All right. So anyone who has an answer, what did you find?
2x squared minus 7x plus 18 minus 31 over x plus 2.
Very good. Oh, oh, looks like this is getting easier. And it will become easier in a little while because there's another way of dividing, especially when you are dividing by an x plus a number. Okay, so I think that one is good. So for the sake of record that you will see on the recording here, so you have done that very well. So I'm happy. Okay. X plus 2. So you have 2x, 2x squared, 2x cubed, my plus 4x squared, then subtract. And then you now have minus 7x squared plus 4x minus 7x minus 7x squared minus 14x subtract. You get 18x. Put down plus 5. Then you now have plus 18x plus 36 subtract minus 31. Very good. Now, I am saying, especially for problems that have just the coefficient of your divisor is a 1, there is an easier way of dividing. But of course, when the coefficient of your the leading coefficient of your divisor is not a 1, then you will have to do this long division process, which I am seeing you are able to very easily do. Okay? So let's now have, and maybe you have learned this synthetic division. Okay? So we'll now talk about synthetic division. So I am showing what you have done a while ago, where we divided 2x cubed, this one, the previous, okay, where you got your answer to be 2x squared minus 7x plus 18. Remainder negative 31. So what I did here is just to show that we did a lot of repetitions. But we will learn how to do synthetic division later. I just want to give, how it was, how it was developed by the mathematicians. They thought, well, maybe we don't even have to consider the variables, because sometimes that's the one that gives us a lot of headache when you're dealing with variables. So really, we're looking at some coefficients, all right? The coefficient is a 2, then you have a 2, a 3, minus 3, and a 4, and a 5. And then you now have a minus a 4 here, okay? So when you subtracted minus 3 minus 4, you got a minus 7, okay? And then 4 and 14, you get 18. And then you got a 36 is when you subtracted from 5, that will be negative 31. But this is how to do synthetic division, okay? So from there, they developed a process. Okay. And this is more exciting and very, it's for me, it's very interesting. Okay. So it says the synthetic division is a shortcut used when the divisor is a binomial. And the form is x minus 8, x minus k. And only the coefficients are used in the division process. And so this is what we will be doing. So when I say x plus 2, that is the same as x minus minus 2. Because we need, this is x minus k. So your k here, therefore, is a minus 2. Okay, from that problem. Okay, so we are changing x plus 2 to x minus k, which is x minus minus 2. And then you just copy all the coefficients. 2, 3, minus 3, 4, 5. Then put the minus 2, which is because we want it of the form x minus k. Then what you do is bring down 2. As you bring down 2, multiply by your negative 2. 2 times negative 2 is negative 4. Add. We are now adding. We are not subtracting, we're adding. Minus 3 minus 4 is minus 7. Multiply. Minus 7 times minus 2 is positive 14. Add. 4 plus 14 is 18. Multiply. 18 times negative 2 is negative 36. 5 minus 36 is negative 31. And so you now have the coefficients. And the coefficients is, since our highest degree of your dividend is cube, the first variable in the answer will be 1 less. So therefore, your 2 will now have 2x squared minus 7x plus 18 minus 31 over x plus 2, which was our answer. So the last is your remainder. And then the first will have a coefficient, an exponent 1 less the highest exponent of your dividend, and move it down until your remainder. So the idea of synthetic division is just use the coefficients and then change your divisor to x minus k. And then put your k, the constant of your divisor, and then do the multiplication and addition. All right, so that it's much clearer, let's have one example here, okay? All right. Okay, anyway, this one is just another example that I have prepared already. When I now have x cubed plus 7x squared plus 10x plus 6, minus 6, I should say. And so because this is x plus 3, then this should be minus 3. X minus minus 3. And then put a 1, a 7, 10, minus 6. Bring down 1. 1 times negative 3 is negative 3. 7 minus 3 is 4. 4 times negative 3 is negative 12. 10 minus 12 is negative 2. Negative 2 times negative 3 is 6. Minus 6 plus 6 is 0. This tells us that the remainder is 0, and therefore, x cubed plus 7x squared plus 10x minus 6 can be factored. And so the factors are just x plus 3 times x squared, because this is 1 less the exponent, plus 4x minus 2. And so this one is your quotient. That's synthetic division. Now, just one more example before you do for about 5 minutes the rest. Here I have 3x cubed minus 2x squared minus 150. You notice that there is no x variable. It's now x cubed, x squared, and immediately you got a constant. When you have a problem like that, provide a certain x. And so the coefficient of that x is 0. All right. So in other words, our problem, because we need to provide the x coefficient, we have to change this problem to be 3x cubed minus 2x squared plus 0x minus 150. So anything that is lacking as the variable, the degree of the variables go down, provide it by putting a coefficient equal to 0. All right, so that's very important. But if they are now 3, 2, 1, 0, 3, 2, 1 constant, you have no problem. 4, 3, 2, 1 constant. But once there's something missing, provide by writing a 0 coefficient. All right, so with that, you just do the same thing. Okay, bring down, so 3, Coefficient is minus 2 with a 0 there for the coefficient of your x, minus 150. Bring down your 3. 3 times 4 is 12. Add 10. 10 times 4 is 40. Add 40 times 4, 160. Add. And then you got your answer to be 3x squared, because the highest power here is 3, then that will be 2. Plus 10x plus 40 plus 10, which is your remainder over x minus 4. So take note that this is x minus 4. This is a 4, because that is already of the form x minus k. So the idea is the sign of your value here should be reversed. If this is minus 4, that will become a 4. If this is plus 3, that will be a minus 3.
Mhm.
Okay, so that's the synthetic division. So that's easy, because you do not divide, multiply, x, and so on. But take note that that only happens when your coefficient of your divisor of your variable is a 1. But if it is now 3x minus 2, 4x plus 5, then you'll have to resort to your long division. Okay. Do this. Sorry. I think that one you can do it very easily. Let me see whether it will take you only 30 seconds.
I think doing the long one is better for me.
You think it's easier to do long one? Answer?
X squared plus 8x plus 21 with a remainder of 67 over 6 minus 3.
Very good. Okay, so isn't that easy? So you just say, okay, 3, 1, 5 minus 3, 4. Then you put down 1. 3. Add. Okay? So it's 8. 24. Add. 21. 63. Add. There. Done. And then you just say x squared plus 8x plus 21 plus 67 x minus 3. Just don't forget that, again, the sign of your constant here should be reversed. If it's minus, that will become a plus 3 and so on. Okay. All right. So last exercise for today, that one. And then we will call this a day. 2x to the fourth plus x cubed minus 3 divide by x plus 2. So if you look at you have a x to the fourth, you have an x cube. What's missing?
X squared and X.
Oh, so with that, you put a 0, 0. Good.
Mhm.
Answer. I was thinking that one is